This is the fifth and final video for section 5.4 on complex numbers. I'm going to show you some examples how to add, subtract, and multiply when you are dealing with complex numbers. These first two problems, I'm calling them kind of mild. They're fairly straightforward. You already are pretty good at these and have the skills to do them fairly well. The first problem, we have a complex number plus a complex number, an addition problem. When we have addition like this, it's really nice. You can just drop those parentheses and then combine like terms. So I see real numbers of 5 plus 7 to give me 12, and then I see my imaginary numbers, 3i minus 5i will be a negative 2i. So I end up with an answer of 12 minus 2i. Remember, the real part, the real number goes first, the imaginary number goes second to get your final answer of 12 minus 2i. Let's try the second one on the right. I have a multiplication problem, I times 3 plus 2i. So it looks like I have an imaginary or lateral number multiplied by a complex number. And you do what you would probably guess is you would distribute that I. So I would end up with 3i plus 2i squared. I times 3 is 3i. I times 2i is a plus 2i squared. Hopefully you recognize that that I squared needs to be changed to a negative 1. So you end up with 3i, and then 2 times negative 1 is a negative 2. I'm going to rewrite this where I have the real part of my number first and the imaginary part of my complex number second. So I end up with the final answer of negative 2 plus 3i. Moving on to a problem that's a little bit more difficult. I'm going to call this medium. It looks like it's a subtraction problem. I've got a complex number subtracting another complex number. And this will be pretty straightforward and easy for most students as long as you can remember that this negative is a really negative 1 there, and I need to distribute that negative 1 to both parts of my second complex number. So the 6 plus 2i won't change, but then I've got a negative 1 times 5, which is a negative 5, and a negative 1 times a negative 4i, which is a positive 4i. The biggest mistake most students make here is they forget to do this second distribution. They forget to do a negative 1 times a negative 4i to get the positive 4i, and what they would get then is this right here would have stayed a negative and you would have gotten it wrong. So to finish this up, we want to combine our like terms. Our real numbers, 6 minus 5 is 1. And then our complex numbers, the 2i and the 4i becomes a plus 6i. And it looks like it's already rearranged correctly with the real number first, the imaginary number second. 1 plus 6i will be our final answer there. All right, on to the last slide. This would be a spicy problem. It was the most difficult one, but I really think you are equipped to do a very nice job on this. You have a complex number, 6 plus 2i squared. Remember that squared means the number times itself. So we actually have a 6 plus 2i times a 6 plus 2i here that hopefully you recognize we could FOIL. 6 times 6 is 36. 6 times 2i is a plus 12i. Then 2i plus 6 is a plus 12i. And 2i times 2i is a plus 4i squared. We definitely have some work we can do with this. We can combine some like terms in the middle. So I have a 36 plus 24i. And then hopefully you recognize that this I squared is a negative 1. So I've got 36 plus 24i minus 4. So let's go ahead and combine those like terms right there. I've got a 32 plus 24i. That is my complex number answer. The real part of the complex number goes first. The imaginary or lateral part goes second. I am going to take a second to show you another way to do this. Some students prefer a box method to foiling, and I think when you get into chapter 6, you really might like this box method. So I'm going to show it to you now. 6 plus 2i times 6 plus 2i. This area model, let's see. 6 times 6 is 36. 6 plus 2i is 12i. 6 plus 2i is 12i again, and then 2i plus 2i is 4i squared which is 4 times negative 1, which is a negative 4. So then what you can do is see you've got like terms here, and you have like terms here that you can combine. So the 36 minus 4 is 32, and the 12i plus 12i is a positive 24i. So you'd end up with the same answer of 32 plus 24i. I really tend to love this, this box method here when we get to bigger polynomials. A binomial with 2 terms times a binomial, that's not so hard to keep track of. But if all of a sudden you have something that has 5 terms in it and it's hard to keep track of, this method works great so you don't forget anything. That'll come in handy in chapter 6. Keep that in mind. All right, so that is it for today. Please don't forget to check in for today's attendance. You want to give yourself credit for doing your work today. If you haven't already, I would do that first thing, honestly, when I start the day. Look at the book assignment, work on it, take pictures, upload it as soon as you can. And we really hope we are doing well. I truly mean that. And if you need help with anything, with math or otherwise, please reach out. This is just such a weird time, and if we can help you, we will. If you have a question that we don't know the answer, we'll work on helping you find out how to get certain questions answered. So please reach out. Thanks so much. See you tomorrow.